We are here to present our solution for the problem statement designing and developing an AI ML based decision support system for optimizing rake formation strategies for SAIL, with initial implementation focused on movements from Bokaro steel plant to CMO stockyards and customer locations. And our problem statement ID is SIH25208. Now, coming to our solution. So, this is our dashboard, and our solution name is SmartRake. So, on the dashboard, we can see it clearly demonstrates the different major metrics which are to be seen or which are to be visible for the given stakeholders. And this basically shows the different lakes planned for a given day and the estimated cost. Demurrage risk is nothing but basically the delay cost, which we call it. And in the same way, we also have different statistics presented on the rake utilization part and the cost breakdown part, which we can see here. And here, our dashboard also presents a recent activity of the different rakes and what has been the different timestamps and different information of the R rakes. And there are also quick actions like navigating it to different running AI optimization in order to understand like which rakes to be prioritized on the first part and which are not. And also there are different parts which we'll be discussing in a detailed manner, and our search tab also gives us the same interface where we can directly navigate to different parts. And here you can see this generate AI plan, which basically generates an planner for the whole strategy for a given day. And also the export report basically gives us the overview of the whole plan as well as the metrics that we have demonstrated on the given dashboard. Now, moving on to the tab of orders and stockyards. This basically consists of the different stockyards that the given system operates in, the steel plant, which we could call it. And these are the different yards in which we operated. We have taken it as a bit of dummy data, and this data is not on a real time basis. We have tried to get it from different sources and put it here. And this basically shows the different kinds of products that each stock yard has it, and the capacity that it can offload per a given day, and also how much does it cost to offload, the average cost which we have taken. And this basically shows the customer orders, and they are mapped across different metrics of the priority status and the tonnage and also the mode that they want the transportation. So now here the status is one of the major thing which basically helps us in planning. If the rail is already assigned, we would just navigate it and check it whether it is on optimized path or not. If it is pending, then we'll create a full-fledged end-to-end strategy plan. And here filter also gives us the whole opportunity, and we could directly export this data also with the export option. And now coming on to the rakes and wagons tab. Here we have whole loading points of the given stock into the rakes. Now we have also taken the different data points here, and also the capacities till which it has been filled, and the total capacity that a given rake can take it or transfer per hour, because we are basically considering it for the mediating point of transferring it from a yard to the rakes. So this is where this loading points come into picture, and these are the available rigs, and we have also mapped the rigs across a given stakeholder or client location, and also the availability timeline along with the cost that it would that the rig would carry with it. And also we have put the utilization capacity that we have done till now if the rake is already in transit. If it is empty, then it has no utilization capacity mapped. And we also have the option of generate formation, where on clicking it, it directly generates the whole formation based on all the pending orders, the available rakes and the operational constraints, and it would provide a whole end-to-end map which we would come back once it is done. Till then we'll explore some other data parts. Here on view details you can see for a given rake, we also have a detailed breakdown of different rake subcomponents and how much is their weightage, and also what is their loaded weight, and what are the products at which it is loaded with. So this is how we have tried to have it, and now it is being generated, so it will take time. Till then we'll just have a look at the other tabs. So now here on the AI optimization engine, we have optimization across three different parts, which is minimizing the cost, delay, and maximizing the utilization. These are the three major metrics on which we have to decide. The trade-off is obviously we cannot optimize three of them at a single point. So we need to take it rid of which is most important at the current point of time for the given client. So in which we have given it in this manner. Now the plan has been generated here, and we could see the plan almost remains same because it has been done. So once again, we are just doing it in order to show on a real world basis. And also here we have FOIS sync, which will basically sync the data automatically at a given time frame, and also we can do it manually. And see, this is on generating the rake formation strategies. This is how it has generated the strategy. It generates basically multiple strategies. So first strategy has different metrics across which it is mapped: the estimation, cost, utilization, and breakdown of the cost. What are the pros and the cons that it could have it, and the AI's reasoning. And now strategy, we could look at other strategy, which is the cost optimization. One is the utilization strategy, which is the optimization strategy, and the other one is basically the balanced approach, which we take a middle ground. So every one of them has their own components and the AI reasoning. Now it is up to the corresponding rake manager in order to choose which strategy to go ahead with. And now hold or release state gives gives us an idea of which rate to be released on a given, if it is loaded, then we could directly release it and it could turn into transit. So now moving on to the AI optimization, this also does the same thing as we have done in the corresponding generating AI plan before, generating strategy before. So now the AI plan also generates it in the same manner. So if I have to minimize the cost, this is how my loading plan should look like. If I have to minimize my delay, then I have then it is generating a plan which basically shows the optimal time delay. So it is showing, and in the same way you can also maximize utilization and it would generate a plan on it. And now we also have a scenario testing in order to monitor and alert on the upcoming situation or in a given situation in order to take a better idea of which hypothesis to go ahead or which planning to go ahead. So in this we have case by case scenarios where if we have the base case of currently having it, if we have low risks, or if we have urgent orders which could come in from a given client, and also if we have any siding outage or any kind of disruptions in the current rake ecosystem, and also if there is any rake delay because of the routing and everything. And it also has multi-destination trade-off, like if a given rake wants to cater to two or three different specific scenarios, other than the route that is planned on an extra. So and also we have live alerts and events which would directly come up on the dashboard, and it would alert based on the warnings, error or success to the corresponding managers and CMO. And now coming on to the final part of our solution, where we have ML prediction system, where the models are on the back end. We would just discuss about the model and the architecture after we have gone through the dashboard completely. Now we have different things, so we could directly upload the data, and also here we could just have the options of enabling confidence intervals, because we cannot optimally predict, AI cannot optimally predict with a complete accuracy. And also the deterministic predictions use the fixed values instead of randomized ML predictions. So it is based on the client's requirement, we could take it up. And also the optimization preferences is something where we put given weightages to the SLA and also cost. So it basically is a culmination of the delivery deadline matching and also the cost. So we would basically have that. And also here we could change the minimum rate tonnage thresholds also based on our understanding. And these are the different constraints which we could try to look at. And here we also have made a chatbot for any kind of queries. We could directly put it, and if they are not able to get any idea of anything, then they could directly navigate to the chatbot and it could help them. So this is all about our dashboard. So now moving on to the current architecture. So we could see that there are different data sources from which the data is ingested. So it can be the SAP or ERP systems from which record their orders, inventories, and stockyard systems regarding the material availability and other parts, and yard sensors and fleet operation parts. So these all data when comes to a logistic control room, so these are manually segregated and decisions are taken manually, which is basically creating the major pain points as mentioned here. The five major pain points are mentioned here, which we have encountered to be one of the some of the significant ones. So, on looking onto the current architecture, we found out that the automation of the system is one of the important thing, but also complete automation could lead to many of the disruptions and risks coming into. So a manual input based automation is something which we have targeted to. So now moving on, so this would be our current architecture, where the same data sources along with the manual inputs of the current stakeholders would come in. And here in the ingestion layer, so we basically, the data is inputted and it is transformed as per in the required format, and then it is stored in the database, operational database, and then the features and the feature aggregates are formed and they are stored. Now the features that are formed are basically going to be gone as inputs to the AI prediction system and the optimization engine, because these are two separate entities, because which basically makes the prediction and the other one optimizes it, and they talk to each other in order to make sure that the final prediction is basically the optimal one. And the optimization can also be of different types, as we have discussed in the dashboard, which can be cost, utilization, time, etc. So now based on all this, then the decision support application comes in, where the decisions and the strategies are given as a set of strategies or decisions, and along with the reasonings, the pros and cons of each of the strategy. And now the human should take the call of which strategy to be implemented. And if the strategy is not being implemented, then a feedback would be given explaining the scenario why it is not implemented and what are the reasons, which would basically help the model to become more and more robust for the real life applications and real life scenarios. Now let's move on to the AI architecture. We have used ensemble model for the AI predictions, which are to be done based on the supervised learning part. And also, we have tried to make sure that we have tried to take the data from different government based sources, and also the client or stakeholder based sale based sources, and different other platforms. And we have tried to make a ensemble AI prediction model, which is basically the ensemble model consists of XGBoost, RF, and also different regression models. And for the ask score part, we have tried to use a classification based kind of model, which is an ensemble model once again in itself. And for the reasoning part and a justified decision based reasoning for any given scenario, and also the pros and cons generation part, we have tried to utilize the Eurus Open BMB model, which basically helped us in generating logical justifications and structured inputs for the control applications, which has found a basic major use case in our scenario, and we have fine tuned the model for our use case. And now coming on to the optimization models, we have tried to use a customized optimization solver, which basically had different components in it. So we have tried to, in the optimization model, we have tried to incorporate the constraint handling as well as scenario based optimization, with some predefined rules at the scenarios where it is necessary in order to avoid the risks and challenges. And also we have used a heuristic fallback mechanism in order to incorporate the optimization in an appropriate and real world scenario based manner, rather than predicting an hypothetical situation or hypothetical decisions. So that's it on our part.